Every message you send is locked with unbreakable encryption. But quantum computers are coming. And when they arrive, nothing will be safe.
So how does that lock actually work? Modern encryption uses two keys. A public key scrambles your message into meaningless noise, so anyone watching the wire sees only garbage. Only the matching private key can unlock it. That single idea protects the entire internet today.
But what makes that lock so hard to pick? The answer is simple multiplication. Take two very large prime numbers, multiply them, and you get a giant number almost instantly. Yet going backward, finding those two original primes is brutally hard. For a big enough number, even the fastest supercomputers would need trillions of years.
Here is where quantum changes the game. A classical computer cracks a code by guessing, checking one key at a time, one after another. A quantum computer works differently. Thanks to the strange rules of physics, it can explore every possible path at the same time. It does not guess faster, it searches everywhere at once.
That power comes from the qubit. A normal bit is either a 0 or a 1, but a qubit can be both at once. A state called superposition, and they stack fast. 10 qubits hold over 1,000 states, and just 300 qubits could represent more than every atom in the universe. Every qubit you add doubles the power.
In 1994, the mathematician Peter Shor found the key. His algorithm turns that impossible factoring problem into something quantum computers love. Finding a repeating pattern, feed it a public key, and a large enough quantum machine could split it back into its prime factors. What would take a classical computer trillions of years might take a quantum one less than a week.
So are we doomed tomorrow? Not quite. The best machines today have only about 1,000 noisy qubits. Breaking RSA could take close to 1 million stable ones, since many fragile qubits must combine into a single reliable one. But that estimate is dropping fast, from 20 million down to under 1 million in just a few years.
Follow the timeline. Shor's idea arrived in 1994. In 2024, Google's Willow chip proved error correction works. Google and IBM target powerful machines around 229. Most experts place Q-Day, the moment today's keys fall, between 2030 and 2035. The gap keeps shrinking.
So who is actually building these machines? On one side, focus startups, IonQ with trapped ions, Rigetti with superconducting chips, and D-Wave with quantum annealing. On the other, the giants, IBM, Google, Microsoft, and Amazon, each pouring billions into their own approach. Two very different camps, racing toward the same finish line.
When that day comes, what falls? Public key systems, RSA, elliptic-curve, and digital signatures all crack open. But not everything breaks. Symmetric encryption like AES-256 and modern hashing stay safe. So Q-Day is not the end of encryption, just today's public key encryption.
And here is the part that should worry you today. Attackers do not have to wait for Q-Day. They can record your encrypted traffic right now and simply store it, waiting for the day they can crack it open. It is called harvest-now-decrypt-later. Government secrets, medical records, banking data, anything that must stay secret past 2030 may already be sitting in someone's vault.
What about Bitcoin? Crypto leans on the very same math that quantum threatens. Every time you spend, you expose a public key signed with elliptic-curve cryptography. Around 6.9 million coins, roughly a third of all Bitcoin, sit behind keys that are already visible. The good news? Networks can upgrade to quantum-safe signatures before it matters.
So how do we fight back? With new locks. Instead of factoring, these rely on lattice math problems, so tangled that even a quantum computer struggles. In 2024, the US finalized 3 new post-quantum standards. And this is not just theory. Apple, Google, Signal, and Cloudflare are already rolling it out to billions of devices. The migration has begun.
How do investors play this? 3 lanes. First, pure play hardware bets. Small, volatile, high risk and high reward. Second, big tech like IBM, Alphabet, and Microsoft, where quantum is just one bet inside a giant. And third, the cybersecurity firms selling the new shields. Different risk levels, one shared thesis.
And the money is pouring in. The quantum market could grow from a couple $1 billion today to roughly $20 billion by 2035. In just the first 9 months of 2025, private investment hit nearly $4 billion, almost triple the previous year. Governments and industry have now committed over $55 billion. Every forecast points up and to the right.
So, is encryption doomed? Not at all. Yes, today's public keys will eventually break, but AES stays strong. The new standards are already here, and the upgrade is underway. The real deadline is not Q-Day. It is harvest now, which means the time to migrate is today.
If this clicked, hit like and subscribe. Tell me in the comments which quantum stock you want broken down next.